Alright, so we're going to talk a little more about special lines. I'm going to hit vertical and horizontal one more time. Again, I'm going to do it fairly quickly because we talked about these in detail in the last chapter, but you still need to know them for chapter 2. So our special line, then we're going to add a couple more special lines. Alright, so remember, the graph of a constant function, the form of where I've got a function f of x equals a number, where that number can be any real number value we want. That's a special line called the horizontal line. Right, it's a flat line. It means it's neither increasing or decreasing. It's flat. So the slope is 0, right? Because there's no change in y. The slope is 0. Right, the y values are all the same. They're all b. So we always hit the y value 0b. And so I drew an example here. This is an example of y equals 3. And so again, the point where my y-intercept would be at 0, 3. There is no x-intercept. There's no 0. And if you look at it, any point on this particular line, the y value is always 3. There's no change in y. X can be anything, but y has to be equal to 3. Right, and so it's a flat line. The slope is 0. Right, flat line, slope is 0, neither increasing nor decreasing. And so that is our horizontal line. The vertical lines, so again, recall, because we talked about them in pretty good detail in the last chapter. I'm just reminding you again, because we'll be using them again in this chapter. You need to know them also for chapter 2. Alright, so vertical lines are not functions, right? Remember, they're not functions. The slope is undefined because it's perfectly going straight up, perfectly increasing, and perfectly going straight down, perfectly decreasing. So there's no way to define that, right? Neither increasing nor decreasing, because it has no meaning in this case. Slope is undefined also because we get division by 0, because there's no change in x. When I divide, I get x minus x is 0, because they're the same value, and so slope is undefined. So the equation, which is not a function, but the equation is x equals some constant, so some real number value. So x can be any real number value, and that equation is a vertical line, where k represents the x-intercept or the 0, and there's no y-intercept. So an example, I have an example drawn over here, x equals 3. Alright, the equation is x equals 3. And I drew a few more points out on this line, so every point on this line, x is 3. That's what the equation is telling me, x is 3. Y can be anything I want it to be, but x has to be 3, and so there's no change in x, so again, if I tried to take 3 minus 3, I would get division by 0, that's why the slope is undefined. So again, regardless of the y value, which can be anything, x value has to be 3. And so I do have an x-intercept. It's at the point 3, 0. There is no y-intercept. And slope is undefined. Right? There's an error in slope. Alright, vertical lines. Special lines you need to know. Alright, we're going to add 2 more types of special lines. The first special line, these are pairs of lines that we're going to look at. Alright, the first type of special line we're going to look at are parallel lines. Parallel lines, as long as they're non-vertical lines, have a slope, right, that exists. Alright, vertical lines are all parallel. All undefined slope lines are all parallel. Right, but these are looking specifically at lines where they're not vertical. Right? Well, non-vertical lines, if they have slopes that are identical, they're parallel if and only if, right, like I said, their slopes are the same. The y-intercepts will be different, but the slopes will be the same. Right? The end part's the same. Parallel lines mean if you graph them, and we'll look at an example of a graph. If we graph them, the lines will never ever intersect. Alright, so we'll look at an example. Alright, so we're going to graph these on our calculator. So y equals 4/3 x plus 6. So there's y1. y2 equals 4/3 x minus 2. Right? Slopes in both of these cases are 4/3, right? Slope in the first case is equal to slope in the second case, which is 4/3. The intercepts are different, so they're different lines. And when we go to graph them, you'll see they're both increasing at the same speed. They're both moving up by 4/3 of a unit per change in x. So they never cross because they're moving at the same speed. Alright, moving up at the same speed in this case because they're positive. Alright, so we're going to graph them. So I'm going to look at the graph now. So I'm going to pop over to my graphing calculator. And so I'm going to go to y equals and plug them in. Alright, so my first line was 4/3 x 6. And then my second line would be 4/3 x minus 2. I'm going to go to my window to look and see what it was. Alright, it's a standard window. If yours is not a standard window, alright, go to zoom and hit standard. And then the other thing I'm going to check is make sure my scatter plot is off. Alright, and it is, so I don't have to worry about my... You want to make sure that's off, otherwise it could mess with your window and mess with your picture. Sometimes it gives you an error saying you can't graph because the scatter plot's on. So I always double check that since we're going to be scatter plotting, and we will do some scatter plotting in chapter 2. So double check and make sure that's turned off, and so I'm good. Alright, so now I'm ready to graph. So there's my first line, there's my second line. So you look at them, they're parallel. Right? They move up at the same speed, and so they're always going to be separated by the same amount. They're always going to be separated by, and actually you can look at the intercepts and see what they're separated by. 1, 2, 3, 4, 5, 6, 7, 8. They're separated by 8, and that should make sense. One of them crosses the y-axis at 6. One of them crosses the y-axis at -2. There's 8 units between them. And they'll always, if I look at any 2 points on this line, there'll always be 8 units between them because they're always going up at the same rate. And so they can never, ever, ever cross. All right, parallel line slopes are the same. Increasing, decreasing at the same rate will never, ever cross. All right, so parallel lines. Perpendicular lines are the other type of line we're going to look at. So again, 2 non-vertical lines. So they have slope, right? Non-verticals don't have slope, so we can't talk about them in terms of slope. So we have slope 1 and slope 2. They're perpendicular if and only if, so that's strict, the slopes make a product of 1. Meaning if I multiply my 2 slopes, sorry, -1. I multiply my 2 slopes, they multiply to -1. And what that means in mathematical terms is the slopes are negative reciprocals of each other. So if one slope's a 2, the negative reciprocal would be -1/2. And we'll do an example of that. And that's what this next one is. So if you look at that, the example shows that. And so it's always a reciprocal. It means you flip it. Negative means one of them is going to be a positive and one of them is going to be a negative. Meaning one of them increases and one of them decreases. And always in the opposite. So you always flip them to get the reciprocal. So if I had 4/3 for one, in order to be perpendicular, it would be -3/4 for the other. So we're going to look at this, and I'm actually going to use the calculator, and then I'll come back to the by hand. So just to make sure you understand what it means to be a negative reciprocal, slope 1 is 2 in the first, -2 in the first equation. Slope 2 is +1/2. If I take slope 1 times slope 2, so I'm going to take -2 times 1/2, right? I get -1 out. And that's what that means. And so in order for things to be perpendicular, that always has to be true. When I multiply my 2 slopes, I get -1. The slope should be, sometimes we say opposite reciprocals, but negative, meaning there's one's a negative, one's a positive. Alright, so first I'm going to go to the graphing calculator and graph it. I already know where they intersect, but I'll actually show you how you find that graphically as well. So go to my graph. I'm going to clear out what I had in there. So hit my y equal to, clear, clear. So I'm going to type in the first equation, which was -2x plus 4. My second equation was 1/2 x minus 6. Should I double check? Those were right? Yeah, those are right. The same window should work, so I should be able to go ahead and graph. Both of them should land in the standard window. There's the first, there's the second. And so I'm going to show you how to find where they intersect. They intersect at one point, and they do make a right angle. Which is why I'm going to graph it by hand on the next sheet. So it's a little hard to tell because of the way the window is not a perfect square. If it was a perfect square, you could tell it was a right angle, but it's not. So it gets a little skewed. But it is a right angle that it's forming. Alright, how to find the point where they intersect. So how to do that on your graphing calculator. Right, first thing, you go to this second trace. You got to do calculations on your calculator. So I'm going to hit second first, then trace, and it'll take me to this window. Fifth one down is what I want to select. I want to select 5. which is where they intersect. And then the calculator asked me to do stuff. It asked me, well, I'm on my first curve, so there's my cursor on my first curve. And on the first curve, I want to get as close as I can, so I hit my over arrow until I get as close as I can to that point of intersection. And sometimes I can get pretty close. Just hit my button one too many times. And sometimes you can just kind of ballpark it. Alright. That looks pretty close. Alright, then you hit enter. And now you're on the second curve, so it means you should be, if you move your cursor back and forth, you should be on the other line, and you are. See, look, I'm on the other line. Usually you don't move it, because you want to keep it at that point where it's pretty close. So as long as it's pretty close, I hit enter again. It asks me to guess, which just basically means, can you move the cursor any closer? Usually, you're right, looks like you're right there, and so I just hit enter a third time. And there it gives me the intersection. Alright, so the two lines intersect at the point 4, -4. So just like I said over here. Intersect at the point 4, -4. Alright, now by hand. So I'm going to use the fact they intersect at this point, and I'm going to use their intercepts. Alright, so the first one, y equals -2x plus 4. The intercept is at 0, 4, and I also know it goes through this point. And so I'm going to use that to graph my first equation. Okay, so there's my x-axis, there's my y-axis, and so my first equation, 1, 2, 3, 4. Alright, so 0, 4, and then 1, 2, 3, 4. 1, 2, 3, 4. -4 is where they intersect, and again I'm going to try to, best I can, draw my straight line. Alright, and so there's my y equals -2x plus 4. Alright, now my second line, I'm going to draw it, and so again I know it goes through this point, and then -6. Alright, so there is where it goes through 0, -6, right? -6 is its y-intercept. 1/2 x minus 6, my intercept is at 0, -6. And then I know it goes through the same point, and again connect the dots. And so my red line is the equation y equals 1/2 x minus 6. And on my by hand graph here, it's a little easier to tell, although it's still not perfect because I didn't have a perfect grid and my numbers weren't quite right. But it really does, even though it doesn't look like it, it really does make a right angle. Alright, perpendicular lines always intersect and form a right angle. Alright, and again, it's a little hard to see because I didn't graph it perfectly. But if I graphed it perfectly, it would be, again, it is. It is a right angle, always. So perpendicular lines always form a right angle. Right? The x-axis and the y-axis are a good example of perpendicular lines. Right? They form a right angle. Their slopes are opposite reciprocals, although they're special cases because one slope is undefined and one slope is 0. So they multiply, you can't multiply them out. Alright, but these are the non-special cases. Alright, so perpendicular lines. Let's do a couple more examples. Actually, I'm going to do the finding perpendicular lines and those in the next video.